In this video, I want to talk about scientific notation, which is another helpful math skill for science class. Scientific notation expresses a number as multiplied to a power of 10. So the format you get is your number, and then it's times 10 raised to some power. The exponent can be positive or negative. Scientific notation is very helpful for small, extremely small, or extremely large numbers. Like we look at this large number, you can see it takes up a lot of space. We've got a whole lot of zeros there, but it can be written as 1.25 times 10 raised to the 14th power. Much more neat and tidy. Similarly, this very, very small number with all those leading zeros could be written as 3.079 times 10 to the negative, raised to the negative 8th. Notice also that scientific notation removes all of those non-significant zeros in the leading or trailing place. In our very large number, we have a whole lot of zeros that are just placeholders. They are not significant. There are only 3 significant digits in this number, and in your scientific notation, you see we only have 3 significant digits. Similarly, in this very small number, we have all these leading zeros that are not significant. There are only 4 significant digits in this number, and in scientific notation, we see those 4 significant digits. There are rules to be followed to turn any number into scientific notation. The first step is to move the decimal to just after the first significant digits and then remove all non-significant zeros. So we have our test number here, 12,500. We're going to take the decimal point from where it lives at the end of the number and move it over to after the first significant digit. So in this number we have 3 significant digits, 1, 2, and 5, and so the decimal is going to be placed there between the 1 and the 2. The next step is to count how many places between where that decimal point started and where it ended, and that determines the power that 10 will be raised to. So if we count all of the spaces here, you'll see that we have gone back 7 spaces from this ending of the number to between the 1 and the 2. So our number in scientific notation is 1.25 times 10 raised to the 7th power. If your starting number was larger than 1, your exponent will be positive. So this very large number gives us a positive exponent. And if the original number was smaller than 1, your exponent will be negative. So this very small number gives us a negative exponent. The positive exponent is telling you that we're taking the decimal point and moving it to the right when we're converting back to this expanded form, and the negative decimal point we're moving it to the left if we are converting back, if we're going from this decimal, going from the scientific notation form into the decimal form. Notice also there's only 1 digit to the left of the decimal in scientific notation. It's always a number, decimal point, rest of the significant digits, so that you never have more than just 1 digit to the left. So I just want to work through 2 examples, and then you'll be turned loose on a worksheet to try this on your own. So let's use scientific notation to round 43029000200. So 43,029,200,000 to 4 significant digits. So first of all, we're going to move our decimal point to between the 4 and the 3 because it's going to go right after that first significant digit. And then we need to count how many places we had to move to get there. So we're starting here behind this last 0. We're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it moved 10 places. Then this number is greater than 1, so our exponent is going to be positive. It will be a positive 10. So then we're going to have to round off our answer to the correct number of significant digits because there are more than 4 significant digits to begin with. In fact, if you look at this, our significant digits actually ends right here in the 200 because the zeros in between those non-zero numbers are significant. So we've got, let's see, I didn't count this beforehand. We have 9 significant digits here. We only want 4. So we're going to look at the first 5 digits. So I've written them down here because when you round off, you look at 1 more digit than what you're rounding off to. So we have 4.3029. That 9 then is going to turn the 2 into a 3, so our answer is going to be 4.303 times 10 raised to the 10th power. And then that is putting this long number into scientific notation. Going the other way with a small number, so we have 0.0000325, and we're going to want to round that off to 3 significant digits. The original number has 4 significant digits because those leading zeros are not significant. So we're going to start by moving our decimal point in between the 3 and the 0 because the 3 is going to be our first significant digit that we run into. The next step is to count the places that the decimal point would have to move. So it's starting in front of all those zeros, and we're going to move in 1, 2, 3, 4, 5 spaces. So we've moved our decimal point from in front of the number, since this is a very small number. The number is less than 1, so we're looking at a negative exponent. And then the last step is to round off to the correct number of significant digits. So again, we're going to go one more digit so that we know how to round off. So we have all 4 digits there, 3.025. The 5, remember, in science has its own set of rules. It only turns numbers into even numbers. So this 2 is already an even number, so it's going to stay there. So the answer will be 3.02 times 10 to the negative 5. So that's your number in scientific notation. Scientific notation can be displayed on many calculators. There is small differences from one brand to another, so I'll just give you a couple things to look for, and you'll have to experiment and see what you have. But in general, you're looking for the EE key and whatever set of buttons you need to push in order to get to it, and that is going to be the 10 times part of the scientific notation. It'll fall before you enter the number for your exponent. So if you have a scientific notation number you're trying to write in, which is 3.52 times 10 to the 4th, you would enter the 3.52, push the EE key, and then push the 4. When you are doing calculations, without using scientific notation, you still may see scientific notation automatically appear in the display if the number is going to be larger or small than the number of digits that are available for your display. And when it's displayed, it usually just has one E. Some calculators also have 2 E's for this part. Most of them don't. So the number up above, where we have 3.52 times 10 to the 4th, would show up on your calculator as 3.52 and then a 1E, the number 4. And you would interpret it, this E4, as being times 10 to the 4th power. Now actually you don't need a scientific calculator. If you remember the rules for working with exponents, I've actually done calculations with scientific notations on a flip phone a number of years ago, but I had to remember how you worked with exponents. So hopefully you'll be able to figure out how to use it on your calculator, and that'll allow you to do these kinds of calculations in chemistry class where we're working with very large numbers or very small numbers of particles and molecules.